Torchzeros. Description: the torchzeros function in ptorch is used to create a tensor filled with zeros. It allows you to specify the desired shape and data type of the tensor. Inputs. Size: this is a tuple that defines the shape of the tensor you want to create. For example, 2, 3 would create a 2 by 3 tensor. D-type: this argument specifies the data type of the elements in the tensor. Common data types include torch, float 32 default, torch, float 64, torch.int 32, and torch.int 64. Device: this argument specifies the device where the tensor will be allocated. You can choose between CPU default and CUDA for GPU. Layout: this argument specifies the memory layout of the tensor. It's usually left as the default torch, strided, but can be used for optimized memory access in certain cases. Requires grad: this argument indicates whether to track gradients for this tensor. Setting it to true will enable automatic differentiation. Outputs. Tensor: this is the newly created tensor filled with zeros, with the specified shape and data type. Steps. The torchzeros function takes the specified size as input and allocates memory for the tensor. The memory allocated is filled with 0 values. The function returns the newly created tensor, ready for further operations. Challenges and fixes. Challenge 1: incorrect shape or data type specified. Sample use case that resulted in challenge 1: trying to create a tensor with a shape 2, 2 but accidentally specifying 2. Fixes to challenge 1: double-check the size argument and ensure it matches the desired shape of a tensor. Adjust the data type argument D-type to the appropriate type for your intended calculations. Challenge 2: tensor is not allocated on the desired device. Sample use case that resulted in challenge 2: trying to create a tensor on the GPU but forgetting to specify device CUDA. Fixes to challenge 2: ensure the device argument device is set correctly to either CPU or CUDA, depending on your needs. If you are using a GPU, make sure it's available and that ptorch is properly configured to use it. Challenge 3: tensor is not tracked for gradients when needed. Sample use case that resulted in challenge 3: trying to use a tensor for backpropagation but forgetting to set requires grad true. Fixes to challenge 3: set the requires grad argument to true when creating the tensor if you intend to use it in a computation graph and track gradients. Torchzeros-like. Description: the torchzeros-like function is a ptorch method used to create a new tensor filled with zeros, having the same size and data type as the input tensor. Inputs. Input 1: input the input tensor whose size and data type will be replicated. Outputs. Output 1: tensor, a new tensor filled with zeros, with the same size and data type as the input tensor. Steps. Step 1: the function takes a single input, which is an existing ptorch tensor. Step 2: it creates a new tensor with the same shape, size and data type as the input tensor. Step 3: all elements of the new tensor are initialized to 0. Challenges and fixes. Challenge 1: incorrect data type, trying to create a tensor with a different data type than the input tensor. Sample use case that resulted in challenge 1. Input tensor torch 1s 2, 3. D-type torch, float 32. Output tensor torch, zeros like input tensor. D-type torch.int 64. Fixes to challenge 1. Ensure the data type used in torch zeros like matches the input tensor's data type. Challenge 2: unexpected shape, attempting to create a tensor with a different shape than the input tensor. Sample use case that resulted in challenge 2. Input tensor torch ones 2, 3. Output insert torch, zeros like input answer. Shape 3, 2. Fixes to challenge 2. Don't explicitly specify the shape when using torch, zeros like. If you need a different shape, use torch, zeros with the desired shape and data type. Torch, ones. Description. The torch, ones function in ptorch is used to create a tensor filled with ones. It offers a versatile way to initialize tensors for various tasks in machine learning and deep learning. Inputs. Size. This is a tuple that specifies the dimensions of the desired tensor. For example, 2, 3 will create a 2 by 3 tensor. D-type optional. This argument determines the data type of the tensor elements. It can be specified as torch, float, torch.int, torch, double, etc. By default, it's torch, float. Layout optional. This argument defines the memory layout of the tensor. It can be strided default or sparse. Device optional. This argument specifies the device on which the tensor should be created. It can be CPU default or CUDA. Requires grad optional. This argument determines whether gradients will be tracked for the tensor. If set to true, gradients will be computed for operations involving this tensor. Outputs. Tensor. A multi-dimensional array filled with ones, having the specified size and data type. Steps. The function takes the size argument to determine the dimensions of the tensor. It allocates memory for the tensor based on the specified size and data type. The memory is initialized with ones for each element in the tensor. Challenges and fixes. Challenge 1. Incorrect dimensions. Sample use case providing a tuple of incorrect size, like 2, 3, 4 when you only need a 2D tensor. Fixes ensure the input tuple size matches the intended dimensionality of the tensor you want to create. Challenge 2. Data type mismatch. Sample use case attempting to perform operations between tensors of different data types, which can lead to unexpected behavior. Fixes specify the same data type for all tensors involved in the calculation. If needed, convert tensors to a common data type using functions like torch, float, torch.int, etc. Challenge 3. Device incompatibility. Sample use case creating a tensor on the GPU CUDA while other tensors are on the CPU, leading to errors during calculations. Fixes ensure all tensors used in calculations are on the same device. If you need to transfer tensors between devices, use tensor to device to move them to the appropriate device. Challenge 4. Memory management. Sample use case creating a large tensor and not releasing it after use, leading to memory leaks. Fixes utilize torch, CUDA, empty cache to free unused memory on the GPU. Use del to remove tensors from memory when they are no longer needed. Torch 1s like. Description. The torch 1s like function is used to create a new tensor filled with ones, with the same size and data type as the input tensor. It is a convenient way to generate a tensor filled with ones without having to specify the shape and data type manually. Inputs. Input 1. Input the input tensor whose size and data type will be used to create the new tensor. Outputs. Output 1. A new tensor filled with ones, with the same size and data type as the input tensor. Steps. Step 1. The function takes an input tensor as its argument. Step 2. It creates a new tensor with the same size and data type as the input tensor. Step 3. It fills the new tensor with ones. Challenges and fixes. Challenge 1. The input tensor must be a valid ptorch tensor. Sample use case that resulted in challenge 1 passing a non-tensor object as input. Fixes to challenge 1 ensure that the input is a p-torch tensor before calling the function. Challenge 2 the input tensor's data type may not be supported by the function. Sample use case that resulted in challenge 2 using an input tensor with a data type that is not supported by the function, such as a complex data type. Fixes to challenge 2 check the documentation of the function to see which data types are supported. If the input tensor's data type is not supported, convert it to a supported data type before calling the function. Challenge 3 the input tensor may have a complex shape, which may lead to unexpected results. Sample use case that resulted in challenge 3 using an input tensor with a complex shape, such as a tensor with multiple dimensions. Fixes to challenge 3 carefully consider the shape of the input tensor and ensure that the output tensor has the expected shape. You may need to use the torch reshape function to reshape the output tensor if necessary. Torch arrange. Description. The torch arrange function creates a one-dimensional tensor with values spaced by a given step. It is similar to the Python range function but operates within the p-torch framework. Inputs. Start the starting value of the sequence. This is an optional parameter, and if not provided, it defaults to 0. End the ending value of the sequence exclusive. This is a required parameter. Step the step value between elements. This is an optional parameter, and if not provided, it defaults to 1. Outputs. Output tensor a one-dimensional tensor containing the sequence of values from start inclusive to end exclusive with the specified step. Steps. Define the starting value start. If not provided, it defaults to 0. Define the ending value end. This is a required parameter. Define the step value step. If not provided, it defaults to 1. Generate a sequence of values from start to end exclusive with the specified step. Return the sequence as a one-dimensional tensor. Challenges and fixes. Challenge 1 end is less than start when the step is positive. Sample use case that resulted in challenge 1 torch arrange 5. 2. 1. Fixes to challenge 1 ensure end is greater than start when the step is positive. Adjust the inputs to ensure start end for a positive step. Challenge 2 end is greater than start when the step is negative. Sample use case that resulted in challenge 2 torch arrange 2. 5. -1. Fixes to challenge 2 ensure end is less than start when the step is negative. Adjust the inputs to ensure start end for a negative step. Torch linspace. Description. Torch linspace is a p-torch function used to create a one-dimensional tensor of evenly spaced values within a specified range. It's particularly useful for generating data points for plotting, sampling, or creating evenly spaced sequences. Inputs. Start the starting value of the sequence. End the ending value of the sequence. Steps the number of evenly spaced values to generate including both the start and end values. Outputs. Tensor a one-dimensional p-torch tensor containing the evenly spaced values. The tensor's size is equal to steps. Steps. The function calculates the difference between the start and end values. It then divides this difference by steps 1 to determine the spacing between consecutive values. Finally, it generates a tensor containing the start value, the start value plus the spacing, the start value plus twice the spacing, and so on, until it reaches the end value. Challenges and fixes. Challenge 1 if the number of steps is less than or equal to 1. The function will return a tensor with only the starting value, regardless of the end value. Sample use case that resulted in challenge 1. Torch linspace 0, 10, 1. Fixes to challenge 1. To generate a tensor with more than one value, ensure that the steps argument is greater than 1. Challenge 2. If the end value is less than the start value, the function will generate a sequence of decreasing values, moving from the start value toward the end value. Sample use case that resulted in challenge 2. Torch, linspace 10, 0, 5. Fixes to challenge 2. To generate a sequence of increasing values, ensure that the start value is less than the end value. Torch, log space. Description. The torch, log space function creates a one-dimensional tensor with evenly spaced elements in logarithmic scale. Inputs. Start the starting value for the logarithmic sequence. It must be a float. End the ending value for the logarithmic sequence. It must be a float. Steps the number of elements in the sequence. It must be an integer. Base the base of the logarithm. It must be a float. Defaults to 10. D-type the desired data type for the returned tensor. Devise the desired device for the returned tensor. Layout the desired layout for the returned tensor. Outputs. A one-dimensional tensor with the specified number of elements, evenly spaced in logarithmic scale. Steps. Calculates the logarithmic space between the start and end values. Generates a sequence of elements within the calculated logarithmic space. Converts the elements back to the original scale using the specified base. Challenges and fixes. Challenge 1. Invalid input values. Sample use case providing non-numeric values for start, end, or steps. Fixes ensure that the input values are valid numeric types float for start and end. Integer for steps. Challenge 2. Incorrect base value. Sample use case using a base value less than or equal to 0. Fixes ensure that the base value is a positive number. Challenge 3. Unexpected output size. Sample use case specifying a steps value that does not match the desired output size. Fixes adjust the steps value to match the intended output size. Challenge 4. Incorrect data type or device. Sample use case using a data type or device that is not supported by the function. Fixes specify a supported data type and device using the dtype and device arguments. Challenge 5. Memory allocation issues. Sample use case attempting to allocate a tensor that exceeds available memory. Fixes ensure that the device has sufficient memory to allocate the desired tensor. Torch.i. Description. The torch.i function creates a 2D tensor with ones on the diagonal and zeros elsewhere. It is used to generate identity matrices, which are fundamental in linear algebra. Inputs. N, an integer representing the number of rows and columns in the identity matrix. Outputs. Out, a 2D tensor of shape n. N representing the identity matrix. Steps. The function first determines the size of the output tensor, which is n. N based on the input n. It then allocates memory for the tensor and initializes all elements to 0. Finally, it sets the diagonal elements of the tensor to 1, effectively creating the identity matrix. Challenges and fixes. Challenge 1. Input n is not an integer. Sample use case torch. IABC. Fixes ensure that the input n is an integer. Use intn to convert the input to an integer if necessary. Challenge 2. Input n is negative. Sample use case torch.i-5. Fixes the function requires a positive integer as input. Ensure that n is a positive integer. Use absn to convert a negative input to a positive value. Challenge 3. Input n is not provided. Sample use case torch.i. Fixes the function requires an input n to determine the size of the identity matrix. Provide the desired size of the matrix as an argument. Torch, empty-like. Description. The torch, empty-like function creates a new tensor with the same size and data type as another tensor, but with uninitialized data. It's a convenient way to create a tensor with the same shape as an existing one without having to specify the size manually. Inputs. Input the tensor whose size and data type will be used to create the new tensor. Outputs. Output a new tensor with the same size and data type as the input tensor, but with uninitialized data. Steps. The function takes a tensor as input. It creates a new tensor with the same size and data type as the input tensor. The new tensor's data is uninitialized, meaning it contains random values. Challenges and fixes. Challenge 1. The torch, empty-like function creates a tensor with uninitialized data. This can lead to unexpected behavior if the tensor is used without first initializing its values. Sample use case that resulted in challenge 1. Trying to use the output of torch, empty-like directly in a computation without initializing its values. Fixes to challenge 1. Initialize the tensor before using the tensor. Use methods like 0, fill, or rand to assign specific values to the elements. Challenge 2. The torch, empty-like function does not preserve the layout or device of the input tensor by default. Sample use case that resulted in challenge 2. You may want the output tensor to have the same device and layout as the input tensor, but this is not the default behavior. Fixes to challenge 2. Use the device and D-type arguments. You can specify the desired device and data type in the empty-like function to ensure the output tensor has the same properties as the input tensor. For example, torch, empty-like input, device, device, D-type input, D-type. Use the clone method. You can clone the input tensor to create a new tensor with the same layout and device. For example, input, clone. Torch, empty-styded. Description. The torch, empty-styded function in PTorch is used to create an uninitialized tensor with specified strides. It allows you to create tensors with custom memory layouts, which can be beneficial for performance optimization in certain scenarios. Inputs. Size a tuple or list specifying the desired shape of the tensor. Each element in the tuple represents the size of the corresponding dimension. Stride a tuple or list specifying the stride of the tensor along each dimension. The stride determines the memory offset between elements in each dimension. Outputs. Tensor and an initialized tensor with the specified size and strides. Steps. The torch, empty-styded function takes the desired size and stride of the tensor as inputs. It allocates the required memory for the tensor. It sets the strides of the tensor according to the provided stride input. The function returns an uninitialized tensor with the specified size and strides. Challenges and fixes. Challenge 1. Incorrect strides can lead to unexpected behavior. Sample use case that resulted in challenge 1. Trying to create a tensor with strides that are not compatible with the size can result in out-of-bounds memory accesses. Fixes to challenge 1. Carefully calculate and verify the strides to ensure they are valid for the given size. Challenge 2. Understanding the concept of strides can be challenging for beginners. Sample use case that resulted in challenge 2. It may be unclear how strides affect the memory layout of a tensor. Fixes to challenge 2. Refer to the PTorch documentation or tutorials on strided tensors to understand the concept and its implications. Torch, Full. Description. The torch full function is used to create a tensor filled with a specific constant value. It allows you to define the desired size, data type, and the constant value to fill the tensor. Inputs. Size a tuple or list specifying the dimensions of the desired tensor. Fill value the scalar value to be used for filling the tensor. D-type optional the data type of the elements in the tensor. Defaults to torch, float 32. Device optional the desired device for the tensor e.g. CPU, CUDA. Defaults to the current device. Layout optional the storage layout of the tensor e.g. strided, sparse. Defaults to strided. Outputs. A tensor filled with the specified fill value. The tensor has the shape specified by the size argument. Steps. Determine the desired size and data type of the tensor. Set the fill value to be used for populating the tensor. Create the tensor using torch full and provide the size, fill value, d-type, and other optional arguments. Challenges and fixes. Challenge 1 providing an invalid size argument. Sample use case that resulted in challenge 1 incorrectly specifying a string instead of a tuple or list for the size argument. Fixes to challenge 1 ensure the size argument is provided as a tuple or list representing pay. Desired dimensions of the tensor. Challenge 2 attempting to fill with a value that cannot be converted to the specified data type. Sample use case that resulted in challenge 2 providing a string as the fill value when the d-type is set to torch, float 32. Fixes to challenge 2 verify that the fill value can be converted to the specified data type or adjust the d-type accordingly. Challenge 3 incorrectly specifying the device or layout arguments. Sample use case that resulted in challenge 3 providing an invalid device name or layout. Fixes to challenge 3 ensure the device and layout arguments are correctly specified. Refer to the ptorch documentation for valid options. Torch full-like. Description. The torch full-like function creates a tensor with the same size and d-type as the input tensor and fills it with a specified value. Inputs. Input 1 input tensor the input tensor whose size and data type the output tensor will inherit. Input 2 fill value float or int the value used to fill the output tensor. Outputs. Output 1 tensor a tensor filled with the specified value, having the same size and data type as the input tensor. Steps. Step 1 it determines the size and data type of the input tensor. Step 2 it creates a new tensor with the specified size and data type, filled with the provided value. Challenges and fixes. Challenge 1 incorrect data type for the fill value. Sample use case that resulted in challenge 1 trying to fill a tensor of type torch, float with an integer value. Fixes to challenge 1 ensure that the data type of fill value matches the data type of the input tensor. Challenge 2 providing an input tensor that is not a valid ptorch tensor. Sample use case that resulted in challenge 2 passing a list or numpy array as the input tensor. Fixes to challenge 2 convert the input to a ptorch tensor using torch tensor before passing it to torch full-like.